Hello, everyone. This is David Ashley. I am the chairman of the Souris River Joint Board. We are pleased to be able to present the preliminary design for the bridge improvements at Highway 41 or Main Street in Velva. The Souris River Joint Board is the entity responsible for implementing flood control throughout the entire Mouse River Valley in North Dakota. The overall program includes improvements in all four counties along the river, Renville, Ward, McHenry, and Bottineau, and is estimated to cost a total of $1 billion. Our vision for this project is basin-wide, meaning as improvements are made in urban centers like Minot, improvements are also being made in rural reaches of the river, including Velva. While our preference would have been to visit with Velva and McHenry County residents face to face, this video presentation will allow us to inform you of the proposed project at Velva so that you may ask questions regarding the project. And we can exchange information in a socially distant virtual manner. The overall purpose of this phase of the project is to remove a hydraulic bottleneck at Highway 41 bridge crossing. By removing this bottleneck, the existing levee system around the city of Velva will be more resilient to overtopping at its upstream end. It should be noted, however, that removing this bottleneck will not cause an impact to downstream lands. Additionally, this new bridge will be compatible with a future levee that has been designed to handle a flood similar to that occurred in 2011 without the massive emergency operations that occurred in Velva that was just under 10 years ago. This project is being designed by HDR Engineering, and Troy Borchard of HDR Engineering will lead the balance of this presentation. Thank you for your time and your interest in this project. We look forward to serving the residents of Velva and McHenry County.
Hi, welcome to the public information presentation pertaining to the Velva Bridge Replacement Project on Highway 41 over the Mouse River. This project is managed by the Souris River Joint Board as part of the system-wide flood protection project, also known as the Mouse River Plan. My name is Troy Borchard. I am with HDR Engineering, and my principal role with this project is I am the lead bridge design engineer. We also have more engineering involved with this project, and their principal roles are with both the hydraulic modeling, which models the flows through this project, as well as all of the roadway modeling for modeling and engineering for this project. Ackerman Estivold is in charge of all of our public outreach, which any questions you would send in or any responses and updates pertaining to this project would be going through them, through the website that you can see located down in the lower right-hand corner of this slide. So this is the extent of our overall project. As you can see, our project is just limited to this area within this shown as pink, and our bridge replacement is in the red. The areas outside of here is shown as excavation to widen the channel through the area. This area here, or depiction here, is of minor levee modifications. And then we have a Glenwood Avenue, which comes in really tight now to the existing bridge, is going to have to be realigned slightly to accommodate being able to accommodate sight distances from the roadway or from the Glenwood Avenue. So during this project and during our project phasing, we were kind of looking at different things and ways we would have to carry traffic through and around the project. So this would have been considered just a local detour. This is on gravel roads, and this would be something that would have been proposed for locals to get around. However, this would not have been approved by NDDOT because this is not on all paved surfaces. So the NDDOT approved detour would have amounted to this: a 50-mile around detour to get from the city of Velva around to the other end of the bridge. Both of these were considered quite excessive, so we decided we needed to look at additional ways or methods to get people through the construction project. So another thing we looked at was, could we build on-site short-term pathways through the project? So we looked at 3 different scenarios within the project area, trying to do the least amount of impacts. This one, of course, had impacts to the residents here. These would have come through, and we've had tie-in over to here doing quite extensive construction. All of these would have added well over $1 million of cost each. None of them were less expensive than the other. More or less, they all kind of panned out about the same. So these were considered too expensive to try also for an on-site or in-town detour. So instead, what we decided to look at was building our project in phases, doing part of the construction at a time. So kind of what we would do is, in phase 1, step 1, we would remove a portion of the existing bridge, put temporary barrier on the bridge, and have the remaining portion of the bridge open to 1 lane of traffic going one way each time, so that you could get traffic through the construction site. We would then build the first half of our new bridge just adjacent in the location where the existing bridge was. We would also then, off the end of the bridge over here, we would have just the roadway there with, again, a safety barrier. We would then start an excavation for where we're going to widen the channel and build our new bridge over off the north end of the bridge. So during phase 2, we would come back in, and at this location, we'd come back in and we would demolish the other half of the bridge. We would then build our new half and tie these 2 halves together, thereby creating the one whole new bridge. And then off on this end, where there is no existing bridge, we then continue the excavation down to the ultimate limit down at this level, and then build the new bridge, having that excavation now underneath the new bridge. This seemed much more feasible and palatable for anybody that would need to travel up Highway 41 to get from the north end of Velva to travel further north. So kind of our overall project, we're going to have excavations on the north side. We'll be building our new bridge through the existing bridge, and then building in riprap on this side, trying to stay within all of our available existing right-of-way. We're trying not to extend the impact of our construction outside of the current existing right-of-way. It was brought to our attention during kind of our preliminary engineering that the city has a desire to build a pathway from within city limits out to the north. And so we have taken that into account in our bridge design. However, at this point, there is no accommodations for pathway either inside, off of either end of the bridge, as that is not part of this project. That is part of a possible future project. So kind of the current conditions as we have it, we have the existing bridge, sitting in the waterway. And what the existing bridge consists of is a 155-foot long bridge with a 32-foot clear roadway. So as the 2011 event happened, you can see the bridge stops approximately here, and water was clear out to here. So the bridge blocked quite a bit of flow, causing more backwater, causing the water surface elevation to rise on the upstream side, so it kind of restricted flow through. So with our project, we are going from that 155-foot long bridge to approximately 262-foot long bridge with a 47-foot wide clear roadway. So the new bridge is going to have much more conveyance, more room underneath for flow to come through. So in the event of the 2011, you can see our bridge extends clear out to here. So the water has a clearer path through. We aren't backing water up or blocking water from coming through this bridge location. So kind of how it looks back in underneath the existing bridge. The 2011 water event was here, and so the water wanted to come clear over to here, which we have the available space. It's just the bridge didn't have the length to accommodate that. So with our new structure, we're now widening out quite a bit, going both to the north and to the south with a 262-foot long bridge, and thereby accommodating a lot wider deck also through this area. So again, our overall project area that we're looking at. What ends up happening is, since we are having to raise this grade for the new bridge going through, we are impacting Glenwood Avenue and these three adjacent approaches onto the highway. So these three adjacent driveways will be affected out to approximately the limits shown here in light gray. You can see the existing roadway is down here in the dashed line. The new proposed roadway is up, and you can see how that is going to have to be raised to allow access up onto the roadway. Glenwood Avenue, existing now, is down about at this elevation, and it will need to be raised up to this point for access up onto the new roadway. Also, Glenwood Avenue's tie-in needs to be moved further south to accommodate sight distance for turning movements or access onto the Highway 41. If this was not moved, the guardrail would block the view, so people trying to come from Glenwood Avenue to get onto the highway wouldn't have adequate sight distance to see oncoming traffic. So for the bridge itself, it is getting raised approximately 2 feet. You can see from the each one of these, every one of these dots is approximately a half a foot. If you look to the side, you can see the elevations. So we're raising it anywhere between a foot to a foot and a half, and we're trying to keep the grade as soft as possible, not trying to increase that over the top, and with our tie-in points off of the end. So what our overall new bridge plan looks like. The existing bridge is this dashed line inside here. Our new bridge now goes out to these limits. The new bridge actually ends here and here, giving us a lot more conveyance for flow through there. The new bridge roadway width now is, the clear roadway width is 47 feet as shown. We have not depicted where the proposed or requested pedestrian path is on this structure. There is an adequate room for it, and we left that off purposefully because it is not determined yet as to which side of the bridge that is going to be placed on. Right now, there is no sidewalk on the west side. There is sidewalk on the east, but it is up to a different project to determine where that will actually cross the bridge. But the accommodations have been made for that to be added onto the bridge, which would include a 10-foot path and up to a 2-foot wide barrier, and still have adequate shoulder width and travel lane width through the bridge itself. So that brings us to the end of our presentation. For any questions that you would have for this project, the questions should be sent to the website shown here. The website is depicted there for questions and comments. The overall project updates can be found at this website, which is It's the overall Mouse River Plan project, which covers the broader project. And then you can find specific to the Velva Bridge Replacement project information at this particular website. I would like to note that any questions sent in to the Mouse River Plan pertaining to this particular site should be directed at this name, the Mouse River Phase VE1 or the Velva Bridge, should be mentioned in any questions or comments sent in to the Mouse River Plan. And with that, I'd like to thank you for your time, and again, send any questions or comments you have into that website. And thank you very much.